We need to develop some new language at this point, math language, and it is going to allow us to evaluate functions. So our language is going to be called function notation, and then we're going to start determining actual numbers to go with our functions when we evaluate them. So, to begin with, function notation. It's just a special way of showing that y depends on x, or that we get to choose our x and then we find out y. So y depends on x. What we're going to say is y equals f of x. Okay, this is a special way of writing. F is the name of our function, and the variable is shown in parentheses. It says, I've got a function, its name is f. The variable that happens to be running around in it is x. This is not a multiplication. That's a very important point. Let me repeat it. This is not indicating multiplication. It is saying, I've got a function, the name is f, the variable running around is x. Now, you'll notice I said y equals f of x. That's because what we're getting here is a y-coordinate for a graph. Okay? So, let me show you how that compares, and we're going to work with a linear function at first here. I can say y equals 9x minus 5. This is an old familiar friend. This is an equation for a line written in slope-intercept form. With my new language, I could say, well, I have a linear function, f of x, and it is equal to 9x minus 5. Now I'm going to just call it a linear function, fn for function. Okay, linear, line, you see the word embedded in that. Now, I would like to know or be able to evaluate this function so that I could have coordinates to graph or use in other applications. So let's find y when x is equal to 2. If I go to my old friend, y equals 9x minus 5, I'd say, okay, find, not thing, find y, and I would just plug in a 2 everywhere I see an x. 9 times 2 minus 5, well, last time I checked, that was 18 minus 5, and y is equal to 13. What that means is I have the ordered pair 2, 13, and I can graph it if I want. I'm not going to. Let's do the exact same thing, but using function notation. We'll evaluate our function. F of x is equal to 9x minus 5. The way I would pose the question, instead of saying find y when x is equal to 2, I would say find f of 2. What that means is evaluate the function whose name happens to be f, and do that when x is 2. Everywhere you see an x, plug in a 2. So here's what we do. We say f of 2, there's an x there, so I'll put in a 2, is 9 times 2, because I've got another x there, minus 5. Well, again, the last time I checked, that was 13. I can say f of 2 equals 13. Once again, I have an ordered pair, and that ordered pair is 2, my x-coordinate, 13, the y-coordinate. So the old way of writing this was we had the pair xy. Let me just move the paper up a little more. And for this particular problem, it was 2, 13 were the coordinates. In the new way, new language, we have the ordered pair x and f of x, the value of the function at x, the y-coordinate. You can think y-coordinate. Well, I could write that 2 f of 2, but that's not very useful other than to tell me I plugged in a 2 everywhere I saw an x. So let me take what I evaluated. F of 2 is equal to 13, and write the ordered pair 2, 13. Nothing has really changed. We're just talking in a different way. And we have just evaluated a function. I think I probably already said that. Let's do another example of evaluating a function. Let's suppose you are given, and oftentimes books will write it this way, given f of x equals 4x minus 3. Find f of negative 1. Well, let's take our 4x minus 3. Everywhere we have an x, we'll put in negative 1. So we'll have 4 times negative 1 minus 3. And that's going to give us negative 4 minus 3, which is a negative 7. We have evaluated our function. F of negative 1 is negative 7. That's the y-coordinate we would graph, and our ordered pair, if we chose to graph it, would be negative 1, negative 7. Now, just to review. First of all, y equals f of x is just a new way of saying y depends on x. So whatever's in here is what y depends on. And it says I've got a function, its name is f, the variable that happens to be running around is x. And to evaluate, you are simply going to substitute for x. That's the end of this segment.